I'm Lacey. I'm Project Manager for the Northern Hub Programme of Work. The programme of work will provide capacity for an additional 44 million passenger journeys across the whole of the North, from Blackpool, Newcastle, Leeds, passing through Manchester. Has the opportunity to provide 30,000 additional jobs for the area, and the wider economic benefits have been calculated at £4 billion. The digital legacy for Network Rail in the outputs for our phase of work will be the three-dimensional models, the geometrical models that the design and build contractor can take forward and the asset manager can take forward as a record.
I'm Mungo Stacy, and I'm the station's CRE. That means I'm the lead stations engineer, and I've had responsibility for leading, developing and delivering the station's design. One of the most exciting things has been the transition to working fully in 3D rather than in a 2D world, and that's actually been a big step change. One of the key benefits of working in this 3D world is that it's much easier to present our designs.
It's helped the clients see the three-dimensional design emerge, not just single disciplines, because in rail it's discipline on discipline. So the track gets a layer of overhead line electrification, gets a layer of civil and structural engineering, gets a layer of signalling, and signal sighting is obviously a safety issue for the rail industry. As these discipline layers are placed on top of each other, the composite product can be seen.
As engineers, we're very technical, and we're used to working with traditional 2D drawings which present the information in a very particular manner. But this project, which is in the heart of Manchester, doesn't involve just engineers. It involves all manner of stakeholders. It involves, for example, the asset engineers on the railway side. It involves people maybe who aren't well versed in technical description. So having this information available in a 3D format, which we can readily visualize, makes it much easier to present our ideas, present our concepts, talk through constraints around that emerging project with other people. One of the challenges with traditional 2D sections and elevations is that you may not have that section at exactly the right area or where the problem happens to be. With the 3D model, what we can do is rotate that model around. We can look at it from different directions. We can orient it differently. We can zoom right in on the problem area, and it becomes very easy to quickly and clearly describe some of the challenges involved, some of the constraints involved in those designs. A great advantage of working in this 3D world with our coordinated models is we can use it to look at the problem of signal sighting. With this project, we're working in a very constrained environment, so we're within the city centre. We've got curves to fit the railway infrastructure into the city. We've got footbridges coming over the track. We've got poles holding up the overhead electrification. So there's a lot that could potentially get in the way of the driver being able to have clear visibility of that signal. So that's one of the real benefits of working with this 3D information, is we can put a camera in the 3D model, we can track the camera along the railway line, and we can look at what the driver can see. And we can make sure that we do have that clear visibility from the driver's position to the signal. What this does is it gives us confidence as the design progresses that we have a design that works. If we didn't have this digital tool, then you would have an ongoing risk to the next design stage. And in fact, that risk might continue actually until you're on site. And at that stage, if you did find you had a problem, you had something in the way, you'd have to move it. That becomes a very expensive process. Looking to the future, it will be interesting to see how we can integrate our 3D model with some of this other asset information. We may be looking in the future, 5 years, maybe less than that, 2-3 years, clicking on a particular structure and it gives us access to the asset records from that. That would be a great way to investigate how our infrastructure is behaving, how its condition is being maintained. If you can look at your picture of that infrastructure on the screen, you can click on it and it shows you that list of the recent inspections of that structure, if it gives you the capacity of that structure. This is true intelligent modelling that we're talking about here, where you can access anything you want to know about that structure. Maybe you could have access to recent photographs of the structure by clicking on the relevant part of the model. I think that's a great vision.
The use of this digital technology has assisted integration, clash detection, and interdisciplinary coordination across the rail disciplines. It will leave a digital legacy for the detail designer, for the constructor, the asset owner and operator.